Formatted I/O functions are used to store data in a file in a readable text format. One of the functions is the fprintf function. We already learned this function before, and it will output the data in the command window. So here, this function is used in file operations. It basically writes formatted data in a user-specified format to a file. It has the following forms. When you look at this form, there's some difference from the form that you used before. That is, the first input value will be the file ID, and the rest will be the same as you used before. So the format string specifies how the data is displayed, or the data is organized in a text. So it has a format string, and it specifies the significant digits, the width of the field, and all other aspects of the output format. This is a table of format conversion specifiers. There's no difference from the one that we learned before. This is a table of the advanced formatted flags. For example, the minus flags meaning left justification of the data in the field. The plus sign meaning that you need to add either plus or negative sign before the value. And the zero meaning the space with leading zeros. Here is a structure of format specifier. It starts with a marker, which is a percentage sign, and followed by an optional modifier. In this case, you will see a negative sign, which means left justified. And then follow the field width, meaning how wide is the field. And within this field, then you can decide the precision. For example, in this case, the field is 12 character wide, and the field for the decimals are 5 character wide. And the last is a format descriptor, whether it's in the form of a floating point or an exponent. This is a table of the escape characters in the format string. You can use fscanf function to read format data in a user-specified format from file. The fscanf function has two forms. The first form has two input data. The first is the file ID, which is from the fopen function. And the second is a format in the data file. And this format is a format string, which is similar to the format string in fprintf function. The fscanf function will return the data and stored in a variable array. The second form of the function call requires a third input, which is the size of the data to read. And also, it will return the data itself as well as the number of data read from the file. This is a table of format conversion specifiers for fscanf. And for example, percentage %C means to read a single character, and the percentage %NC is to read n characters. And you will see that most of the specifiers are the same as the specifiers in the fprintf. sprintf function is exactly like fprintf function. The only difference is it writes the format data into a character string instead of a file, and that character string can be stored in a variable. And the form of the sprintf function is like this. And when you look at this form, it will be exactly the same as the fprintf function. But the only difference is that it will not output the string on the command window, Instead, it stores a string in a variable. There are two functions that can read a line from the text file. Those functions are fgetl and fgets. The difference between the two functions is that fgetl will exclude the end-of-line characters, while fgets will keep them. They have the same form, and they took the file ID as input. If the function encounters the end of the file, the value of the line will be set to -1. What are the pros and cons of formatted and binary I/O functions? First, the format I/O operations produces formatted files, and those files are actually text files that can be read by other programs. So that's a benefit of sharing the data between different programs or between different computers. However, if you use the data in a format file, the MATLAB must convert the data into characters and then save the data into the file. Or, if you want to read the data back, it has to convert the characters back to the internal data format so that it can be used by the program. Unformatted file usually is called a binary files. It copies the information from the computer's memory directly to the disk. So there's no conversions at all. So it is much more efficient than the formatted file. Because of this, binary operations are much faster and the data occupies a much smaller amount of disk space. This table compares the formatted file versus unformatted file. For formatted file, it can display data on an output device directly. However, the unformatted file cannot do so. And the formatted file can be transported easily between different computers. However, the unformatted file has difficulty to do so. Unfortunately, formatted file requires a large amount of disk space to store. However, for the unformatted files, it is relatively efficient in disk storage. Because of the conversion involved in reading and saving the data, so formatted file operations are relatively slower than the unformatted file operations. And finally, the format files usually incurs errors because of the long rounding issues. But for the unformatted file, no such rounding errors will occur. MATLAB provides a few advanced functions for the control of file operations. For example, the function exist determines whether or not a file exists before it is opened. It is very helpful to check if the file exists before you want to open it to read, and this can avoid unnecessary error. When you open a file, there's a file pointer created. That file pointer will point to the beginning of the file when you open. The function fgelf tells if the file pointer points to the end of the file, and the function ftel will tell exactly where the pointer is inside the file. You can also use frewind or fseek to move the file pointer within the file. Function ferror will provide detailed description of the error generated from the I/O operation. Here I would like to make an additional note on the file pointer. For example, if you open a file, the file pointer is pointing to the beginning of the file. Let's say if you are going to read 10 bytes, so the pointer will move 10 bytes and pointing to the 11th bytes in the file. And therefore, next read operation will start from the 11th byte. Similarly, if you are working on a text file, when you're using the fgets or fgetl, so every read of either function will move the pointer to the next line in the text file.